Hi, it's Tim. Welcome back to the corner. Today we are looking at the Amiga 500 Plus once again. This is the same machine that we looked at before. It had what we thought may be a 42MB Agnus chip, but some new information has come to light and it is worth having another look at it, and let's do that right now. So a number of viewers commented in the previous video that they'd seen a video from CRG and he had a machine that had a very similar problem, and that video is linked up in the corner so you can go and have a look for yourselves. The problem is not quite the same. His machine has a green screen and 10 flashes on the drive light. Mine has a black screen and 10 flashes on the drive light. Now the difference between that is that the list of error messages does not include 10 flashes and a black screen, so maybe the screen just doesn't work and the problem is still the same. But there are one or two things that we can try, and the first thing that we're going to try is diagram. Now this is a diagnostics ROM that basically you plug it into the Amiga and it runs through a whole bunch of tests, and because it doesn't, or rather because my screen is not working, this will actually output to the serial port. And so we have got one of these things, which is a RS-232 to USB cable, and one of these things which is a 25-pin to 9-pin cable that I basically made it up myself, because the only cables that I had actually that did this conversion were actually null modem cables, and this is also a null modem cable, and so of course two null modem cables cancel each other out and won't work. So I had to knock up a quick, basically straight through. It's just a 3-wire interface, TX, RX and ground. Nothing much to it, but we are going to hook that up, and we are going to hook this up, and we're going to see what that says and if it has any bearing on what CRG's video found, and we can then go a bit further from that. I'd like to thank PCBWay for sponsoring this video. They make high quality printed circuit boards, and they made this for us, which is a adapter board that we designed here on the channel and we had made through their instant quote service. They also made these, which have just arrived, and this is for a future project that is going to be an EEPROM programmer. Look out for that on the channel. In addition to PCBs, they make high quality CNC, they do 3D printing, they do a whole host of other stuff, and running right now is their design competition, and you can enter that and win big prizes. So thanks again to PCBWay, and now back to the video. First thing we're going to do is take the machine apart. Now I've already taken the screws out, so it's just a matter of lifting the case off. Put on the old anti-static, and you'll see I've already taken the EEPROM out, which there it is, and we can put the diagram in. Now this is a 42-pin socket and this is a 40-pin ROM, so you need to make sure that the bottom pins are at the bottom of the socket. There we go. Okay, I'll turn the screen on even though it's not going to show us anything. Now the serial port is connected to the serial adapter, which goes into the USB hub, which goes into the MacBook, and on the MacBook we are going to run terminal, Let's just make it a bit bigger. Okay, that tells us what devices we've got attached, and the TTY is, or rather the RS-232 port is on TTY.USB serial -120. So we just run the screen command and set that to 9600 baud, and hopefully anything that comes out of the Amiga is going to appear on the screen. So let's turn it on. I haven't tried this before, so that's interesting. We've got a transmit light on. But we're not seeing any data on the screen. Now, I did try this with a known working Amiga 500 and it definitely does come out. So, check the diagram is in right. Yep, it's the right way round. Let's give it a minute in case something happens. Okay, let's have a poke around with the oscilloscope. So let's just have a look at some of the RAM chips just to see what they're doing. So that's IO4, which is not very impressive. I3, which is also not very impressive. On the other side, I1, I2. So we've got no data basically on the data bus coming off the chips, or at least it's being forced down to that horrible looking signal there. Let's just look at some of the address lines. Let's do something. That's VCC, A3, A2, A1, A0. Let's just have a look at the EEPROM and see what's coming off here. So this is the data bus. Definitely stuff happening. That's A11, A12, A13, A14. Well, we've got some life at that end, and we don't have any life coming out of the DRAMs. So, does that point to this stuff around here? I suspect it might. Now, without knowing what any of this does, I'm just going to poke a few pins. Ah, that's what we were seeing on the DRAMs. That looks fine. That's what we were seeing on the DRAMs. That looks fine. Bleh. Fine. Bleh. Fine. I'm guessing that's a clocky McClockface. So, is the problem down here 74F244? I've got some LS244s. 74F373. These are 373s. That's a 373. I think these deserve a look. And I think the board underneath them deserves another look. And this area around the battery also I think deserves another look. So these ought to come out and we can do another check on the PCB there and maybe strip it back again. because it's quite possible we missed something there before. I mean, it looks quite clean, but is it? And are these chips okay? That's another question. Right, so that's what we'll do. I've taken the board out of its case, and so now I can remove these ICs. It's these 6-7 chips here. I don't think we need to remove that one necessarily, but we will keep an open mind. This first one can come out very quickly. And we are using the medieval looking demon pump and solder wick, solder IPA flux, etc, etc. Right, this gets lots of blobs of solder everywhere, so we will look forward to that. Okay, now we're just going to apply some heat to the back of the board to get Okay, that's done. Now the camera ran out of battery while that was going on, so you probably missed a load of it, but the chips are out, and so we now need to clean up the board and clean up the bench and test the chips. I can't see anything particularly just from looking at it, but we'll have to look at it under a magnifier. Okay, so those are the chips, and this is all the solder that came out. Now that goes into the desoldering gun every time we use it on sort of a big chip or several big chips or just several chips. So you can see why it constantly needs cleaning, and that glass tube is a real pain to get in and out. So the manual version is actually easier to use. I'm just going to sweep that into the bin. Okay, the chips are all out. I've put them through the Mini Pro tester just to see whether they worked or not, and this one, which is the 74F139, is the one that goes here. This one proved to be faulty. The others tested out okay. I do want to go through this board and go through it with the fiberglass pen and clean up this area again, and take it right back, take the solder mask off, just to check that there are no problems with the traces, particularly around here. I don't think there are. In taking this chip out, it's got these 3 pads here and these 3 pads here. This pad here got lifted somehow, and that goes from this pin up to one of these, and that is going to need a Bodge wire to fix that, but I'm going to clean that up as well. So we know that this one chip is faulty. I don't think these others are. That is the chip that controls the CAS signal to the DRAMs, so that not working is definitely going to give a problem with the memory. Whether that's our only problem or not is another matter, but we do need to fix that, and then we shall see what's what. Okay, so I'm going to clean this up some more, and then I'm going to put some sockets in and paint over with UV resistant jobby stuff. So let's do that. Okay, after cleaning it up, we can see that all the traces are actually pretty good, and there is continuity between all of them. It's hard to see with the camera in the way. There we go. If we actually get the right trace going to the right place. It goes right the way through to there. So yes, these all have been followed through, so I'm happy with that. I think we can put sockets back into these and put chips in. I want to put a new chip in here and of course do this Bodge wire. I'll do that on the back once the socket is in. And I can put this capacitor back in. This is not a good thing. I literally just picked up the board and this crystal just snapped off. So this is going to need to be replaced as well. I definitely don't have one of those, so I'm going to have to order that. I've got some of this UV curable solder mask, or solder mast as it says. I've never used this before, so this is going to be a first time. It didn't come with a plungery thing, so this is a plungery thing out of a syringe of solder paste. Hopefully it will work. So basically we just want to go over this stuff here on the top layer and then cure it with a UV light. I don't know how runny it is, we shall find out. Not very seems to be the answer. Let's just use a cotton bud and spread it around. There we go. Put the lid back on. Okay, that seems to be okay. So now we can start putting pieces back together. I still need to get a new crystal for the real-time clock, but the Amiga should work without the real-time clock because the old 500 original did not have a real-time clock. So we should be okay. Now let's put this capacitor back. Goes between there. Put some flux on it. Okay, that's good. Now we can start fitting sockets. Yeah, I'm using posh sockets because it's what I had. So I'm just going to mark which pin that is that needs the Bodge wire, and that goes to number 11 down here. 1, 2, 3, 4, 5. Okay, now before I solder all the pins, let's just check that the socket is the right way around. That one is not. I can't believe I screwed that up again. That one's right, that one's right, that one's right, that one's right, that one's right. And on the cheap socket too. I suppose that's fortunate. This is why you want to only solder the two corners and then do a sanity check. Definitely the right way around this time. Sanity check again, that's correct, that's correct, that's correct, that's correct, that's correct, that's correct, that's correct. Okay, let us put this bodge wire on the back. Now the wire goes from pin 5, we can mark it on the back, so pin 5, 1, 2, 3, 4, 5, and the 11th pin down, 1, 2, 3, 4, 5, 7, 8, just so that we know where to go, and a little bit of wire. There we go. And I'll just stick that down with a little bit of Kapton tape. Just to hold it in place. So there we go. Bodge wire done. Now we can start putting the chips back in. Okay, the logic chips are in 244s and the 373s. And I had to order one of these, so that has now arrived and we can insert that. Squeeze the legs. This should be a whole lot easier because this is a standard double wipe socket. There we go. The downside of these turn pin sockets is they are the devil's own job to put chips into. Also, while waiting for this to arrive, I got some crystals. So I can put one of these in here. We only need one. There we are, job done. Okay, so I guess it's time to plug it all in and see if it actually works, or if it's made any difference at all. So everything is plugged in. I've got the power attached, I've got the modem cable attached, the red light is on, that signifies power coming from the Mac. The screen is turned on and plugged in. Now let us see what, if anything, changing that chip has done. 3, 2, 1. And nothing. That has made no difference whatsoever. Let's just power up the scope. Take a look at what's on the data lines. You won't be able to see this because I don't have a camera on the oscilloscope. Put that on. No, that is exactly the same as it was before. I've also replaced these 6 other chips with new versions of the same thing. So now I am going to look at the Agnus and go through all the signals on that and see what we can see. Okay, I've pulled out the old regular Amiga 500 just so that we can do a comparison of the 8372 Agnus with the 8375 Agnus, and particularly with the RAS and CAS lines. Now, this is the 8372 pinout, and the lines that we're interested in are down here, RAS0, RAS1, CAS-U and CAS-L. And this is the 8375 pinout, and you'll see that the CAS-U and CAS-L lines are moved and the RAS1 and RAS0 lines are in the same place. So this is one reason why the two chips are not interchangeable, but we are going to have a look and see what the signals are like. That is CAS-L, that is CAS-U, That is RAS 1. And that is RAS 0. Okay, it's been suggested that possibly the problem is with the contacts on this PLCC socket rather than the chip itself. So that's something that I shall investigate and pull this out and give it a spray with some Servicel. You might notice that this is actually a different 68000. That's because I swapped over the chip, the CPU, with my regular A500, and that proved that the CPU is in fact working fine. I haven't swapped it back. Okay, let's use the magic PLCC removal tool. There we go. And spray some Servicel brand deoxit. Hopefully that's going to do the trick. Let's put him back. Quick click, power and monitor, and see if it comes back. And no. That's just a plain blue screen and nothing's going on. Right, we've been on the eBays and we have got this. Now this is a replacement Agnus. So before I open the package, I'm going to put on the strappy strap, because this was one expensive IC and we don't want anything to go wrong with it. So. Okay. The mat is grounded as well as the strap, so that's okay. And there we can see 8375. 8375, this is dated 3691. Okay, so let's take the old Agnus out. PLCC chip extractor. There we go, one chip extracted. Now, what I've also got is a bunch of PLCC sockets, because I've also been told that these sockets that Commodore use are pretty crap. And so hopefully these ones are less crap, although I immediately noticed that some of the pins are actually bent. I'm going to try the replacement chip first and then see if we need to put the socket in. Okay, there's the pin 1 marker, there's pin 1. And that's in. Double check, pin 1, pin 1. Okay, let's plug it in and see what it does. Okay, the camera is set up, the screen recorder is recording, the terminal is attached. Let's switch it on and see what it does in 3, 2, 1. And that does absolutely nothing. So exactly as before, the power light has come on, the red light has come on, the yellow light has come on. Nothing has come out of the serial port. We don't even have a black screen. Bum. Now we all know the poor reputation that Commodore has for its sockets. So I've had a look on the scope and we have 28 megahertz coming in from this clock, and it comes in on pin whatever it is here. And the Agnus divides that signal down into 14 and 7 megahertz signals, which it then feeds to the CPU and other things around the circuit. But it's not doing that. So there's no 14 megahertz output and there's no 7 megahertz output, which is why there's nothing on the address lines and there's nothing on the data lines, because nothing is being clocked. So maybe this is a duff Agnus, in which case it was a bloody expensive duff Agnus, but also maybe the socket is crap. So in a last act of desperation almost, I'm going to take the chip out and replace the socket. Okay, the chip's out, the soldering gun is on, let's get to it. Okay, that was a lot easier to unsolder than many other sockets. It's still going to need a little bit of heat to free it. Let's put the heat gun on. Okay, there are a couple of pins that got left behind, but I think on the whole that came out rather cleanly. Now the new socket should go in, there's a little arrow indicating pin 1. That's the old one, you can see the arrow is there. And the extractor tool grooves are there and there and there and there, so that's the right way around. It just slots in like that. Just bung a bit of tape across it to hold it down. There we go. We'll do the usual thing of tacking down the corners and then making sure it's properly seated. Let us solder it in. Good. I think it's good. So once again, double check. Pin 1, pin 1. Goes in with a nice snuck. Right, we are on the regular kickstart. Power to the power supply. We've got a black screen again. It hasn't necessarily started the computer, but that has at least got us back to where we were before. And yes, we've got clock signals. Look at the RAM. The RAM is exactly as it was before. Yeah, 0 volts. 0 volts on the RAM outputs. Okay, diagram, new Agnus serial port. And nothing. You get the black screen, but that is it. Okay, let's replace the new Agnus with the old Agnus. Right, and once again we will switch it on. Black screen, yellow light is on solid, no output. Pooh. I think I've gone as far as I can with this Amiga. At least I don't have a clear idea of where to go next. If you've got any ideas or you've spotted the obvious mistake, then please let me know in the comments below. Otherwise, what's next for this machine? I don't want to scrap it. Maybe I could get an A500++ motherboard and scavenge this to make a new one. It's a thought. Let me know. In the meantime, please like and subscribe. It really helps small channels like this one. And take a look at this video here. I'm sure you'll like it. I will see you next time. Bye.